Hi everyone! So by now you should have watched the required practical video on density. So this is to help you in filling in the summary sheet. So for the density required practical, the whole point of this practical is that substances have different densities, and as scientists we need to know how to calculate those densities. To calculate an object's density, you need to have the mass of the object and the volume of the object, and then you can substitute these values into the equation density equals mass divided by volume. Now, just a few notes on this equation. The standard units. The standard unit for mass is kilograms. For volume, it's meters cubed. And density is kilograms per metre cubed, kg/m cubed. However, there is a chance sometimes in an exam where you could be asked to calculate density in grams per centimetres cubed, or also convert measurements into the standard units, kilograms and metres cubed. Today we are not going to focus on this, however, we are just going to focus on the methodology for density. Now, there are two different methods depending on the type of object you have. So we will look at each of those methods individually. Okay, so the first question you've been asked on your sheet for this practical is to give the equation that links density, mass and volume. And you should be able to complete that now. So pause, go over to the sheet and see if you can complete it. So let's check. You should have density equals mass divided by volume. So as you can see on the rest of your sheet, we are going to look at regular objects and irregular objects. Now, when we're talking about regular and irregular, we are referring to the shape. So regular objects are shapes that you can take measurements from quite easily. So the example I'm going to use today is a cube. You could use a sphere or a cuboid, but it is something you could measure. So how can we calculate the density of a cube? Well, we need two things. We need the mass and the volume. So let's take you through that. So first, we would measure the length, width and height of the object using a ruler. And that can then be used to calculate the volume of the object using an equation you've probably seen in maths. Volume equals length times width times height. When we've got that, then we can calculate the mass by placing the object on a balance and recording that mass of that object. Make sure that you have zeroed that balance first. As you can see on the image, you can see a button that says tare. That resets that balance to 0 before you place the object on it. Once we've got the mass and the volume, we can substitute those numbers into the equation density equals mass divided by volume. So back to our sheet, okay? I want you to pause and have a go at filling in the apparatus list. Okay, you might want to also find a diagram to add into this box. Replay when you're ready to check. So a nice straightforward start. The equipment we would need for this is a ruler and a balance. Now for your method, on the next slide, I'm going to put our pictures from earlier on. I want you to pause and use these to help you to write your method, and then I'll reveal the answers for you to check afterwards. So on the screen now are the images from earlier on. Pause, have a go at writing the method, and then when you've read it, resume this video and you can check your answers. Okay, so let's see if you got the same as me. First, you would measure the length, width and height of the object. This can then be used to calculate the volume of the object using the equation volume equals length times width times height. Then place the object on a balance and record the mass of the object. And then now you've got the mass and the volume, you can substitute those into the equation to calculate the density. What happens if it's not a regular shaped object? In the earlier video, they showed you a different piece of equipment called a Eureka can. So our next method will explain to us how to use that Eureka can. First, we need to fill the Eureka can until the water is level with the hull. Then we need to place an empty measuring cylinder under that nozzle and then place our object into the Eureka can. As you can see in this image, water will be displaced into the measuring cylinder. The volume of the water that's being displaced is the same as the volume of the object. So now we have the volume of our irregular shaped object. Then we can place that object onto a balance and record the mass and substitute the mass and the volume into that equation to calculate the density. So again, back to our sheet. What equipment will we need for this? Pause, write them down, and then come back to check. So you should have that we need a balance, again, a Eureka can, and a measuring cylinder. Now for our method, again on the next slide, I'll place the images to help you write your method, and then you can come back and check. So here we go. Pause, go back to your sheet and have a go at writing your method. Okay, so let's check now. First, we're going to fill that Eureka can until the water is level with the hull. Then place an empty measuring cylinder under the nozzle and place the object into the can so that then the volume of water displaced into that measuring cylinder is the same as the volume of the object. Then we can measure the mass of the object using a balance and substitute those numbers into the equation to calculate the density. I hope this helped you all with your work and speak to you in the next video.